For this lesson, I'd like to look at linear functions. That's anything of the form f of x, a function, is equal to m times x plus b. M is called the slope, and b is the y value of the y-intercept. For slope, this is often referred to as rise over run. So I have a formula for slope over here that we'll get to in our next example. But just to understand the idea of slope, let's look at example 1. I give you two different linear functions. If we start with f of x is equal to 2x minus 1, the slope of this is 2, or as a fraction, 2 over 1. The y value of the y-intercept is negative 1, and this is enough information to understand what the graph of the line has to look like. Here's what I mean. The y-intercept is the value on the y-axis, and this is saying that it has a value of negative 1. So I'm going to put a point at 0, negative 1. Now the slope is 2, or 2 over run. This is the rise over the run. So if we start at this point, if we go over 1 and up 2, we end up on the line again. So I'll draw a point here at 1, 1. The slope is going to work for any 2 points you choose on your line. So if you were to go over 1 and up 2 again, you end up on your line. And this happens repeatedly. In fact, the line you get goes between all the points that I have drawn. So one thing to point out is if you're given a linear function and you know its slope, you know whether it is increasing or decreasing, and you know where it crosses over the y-axis. Now if we compare this to the linear function, we'll say g of x is equal to negative 3x plus 2. Here the slope is going to be a negative 3 over 1. The y-intercept is at positive 2. So if we want to understand what this graph looks like, same thing. At 0, 2, I'm going to place the y-intercept. But now since the slope is a negative number, I know it's decreasing. This means if you go over 1, you're going down 1, 2, 3 places to get your other point on the graph. So that's right here. So we could draw a whole bunch of points, but once you have 2, that's enough to say that, okay, well, this one is decreasing. If I go to the left, it's moving upward, but here we go. This has a slope of negative 3. The first one had a slope of positive 2. So slope is nice. It tells you, is the line increasing or is it decreasing? And it also tells you by how much. If we had a slope of, let's say not 2, but 5, that line would be even steeper than the one that we started with. So slope is good. Is it increasing? Is it decreasing? And by how much? For example 2, I want to find the equation of the line that goes between the points negative 2, 5 and 6, 1. I'm going to plot those on the graph given below. So that is negative 2, 5 and 6, 1. There's definitely a line that goes between these 2 points. So I'll try to draw that on here. So here's my equation. Not perfect, but whatever. It's trying to get the point across that there's definitely some line going between these 2 points. So what is it? It has the form f of x is equal to m times x plus b. So if you find the slope and you find the y-intercept, that's enough to determine the equation. So on the previous page, I had a formula for slope. It was y2 minus y1 over x2 minus x1. This is the idea of rise over run, just stated in a different way. I'm going to label my points x1, y1 and x2, y2, and I'm going to use this formula to figure out, well, what is the slope of this line? So a couple of things to point out is, well, I know whatever the value for the slope is, it's going to be a negative number, and this is not a very steep line, so I'm not expecting the number to be very big. but let's actually compute what the slope is equal to. All right, according to my formula, I'm going to do y2 minus y1. In this case, that's 1 minus 5. And I'm dividing by, now it's going to be x2 minus x1. So that is 6 minus negative 2. So anytime you subtract a negative, I know that's going to change to addition. If I take this value and I simplify it, that's 1 minus 5, which is negative 4, divided by 6 plus 2, which is 8, and this is negative 1/2. This makes sense if we look at the equation. I was expecting a negative number, but not one that is very big. So that's what negative 1/2 means to me. It's decreasing, but not by very much. So now the only other thing that we need is the y-intercept, which, I mean, my sketch was not very good, but I mean, it kind of looks like it would have to be 0, 4. And if we use the idea of slope, if we start at this point and we go down 1 and over 2, well, okay, that would take me to the point 0, 4. But if you couldn't see that from your picture, or maybe you thought your sketch wasn't very good, you can also solve for what this is equal to as well. So I want to try that. So what I'll do is I'm going to go to my function. F of x is equal to mx plus b. And I'm going to plug in all of the information that I know. And up to this point, that's just the slope. So I have f of x is equal to, I'm going to put negative 1/2 in place of m, copy down x, and put plus b. My goal is to figure out what is the value of b. Here I have 2 points, which is an x and a y value. And if I look at this expression, I can put one number in place of x, figure out what the corresponding y value is, and the only thing I won't know is b, meaning that I'll be able to solve for it. You can use any point that you would like to. I'm going to, I guess, choose 6, 1 at random. I don't think it will matter, but I'm going to use 6, 1 to help me figure out, well, what is the value of b? All right, that means x is equal to 6. I'm going to put that in place of all of the x's. So we have f of 6 is equal to negative 1/2 times 6 plus b. F of 6 is the y value at 6, so I can replace that with 1. 1/2 times 6 is negative 3. And the only thing that I don't know is b. But if I add 3 to both sides, well, you know, I get that b is equal to 4, which is kind of what I expected from my picture. And so this gives me a final answer of the line that goes between the 2 points is negative 1/2 x plus 4.